Hi, I'm Chris from Primary Engineer. Welcome to our online interview today featuring Alyssa Carson. Alyssa is an astronaut in the training, and it's really exciting that she's able to join us this afternoon. Before we get started, I will quickly run through what's going to happen in this session. The first part will be Alyssa talking about herself and what inspires her, what she does, what's involved in being an astronaut in training. And then after that, we will be opening this up to a Q&A session. So please feel free to type in your questions at any point during the session today. And then hopefully when we get to the Q&A section, we can get straight into answering as many as possible. At the bottom of your screen, there is a Q&A section where you can start typing in your answers. If you can please use that Q&A facility, and you'll see that there at the bottom of your screen to use. So before we get started with Alyssa, just a quick recap of what is, if you were an engineer, what would you do? And this is our national competition, which requires people to think about problems and how to design problems. It's about inspiring young people to look around the world and to design solutions to those problems. What's really exciting about today is that Alyssa is going to be inspiring us to think about not just problems in our world, but problems in space. To think about what potential problems there may be for space travel, space exploration, and what life might be like on other planets. So it gives you a really good opportunity to pick Alyssa's brain, find out what she thinks might be problems that you might want to address and solve. And also, please do check out all of the other resources on our website. So after the interview with Alyssa today, make sure you go onto the website and have a look at those. And there are other opportunities to meet and interview other engineering and STEM professionals online, just like we're doing today with Alyssa. So please do join us with those as well. So without any further ado, I will introduce you now to Alyssa Carson, and she will be able to tell you about herself and about what it's like to be an astronaut in training and what the future holds for her and potentially for us. So handing over to you now, Alyssa.
Yeah, thank you so much for that little intro. I'm really excited to be talking to you guys today. Really kind of like what you just heard. I really want to start by just covering a little bit about who I am, what exactly I do, so that way you guys have an idea. And then we can also talk a little bit about space, cover a little bit of the problems, maybe have you guys start thinking about a lot of the problems that we have with space, just kind of in general. And also as we have hopes of doing more in space, possibly going back to the moon, going to Mars, a lot of exciting stuff's happening soon in the space industry, but with new ideas comes a whole new set of problems that we're hoping to solve in the next few years to get ready for all that. So we'll cover a little bit of that, and then like also, just like what you heard, keep dropping questions into the chat because I want to talk about what you guys want to know. So definitely put any and every thought you have into the chat and we'll get to them in just a minute. But pretty much for me, I've been interested in space ever since I was a little girl. So I think I was 3 or so, I don't remember exactly, but that's about the time when I first found out about space and about really astronauts and anything like that. So I went and I asked my dad all these questions about space, about Mars, just anything that I could possibly ask. No one in my family had any sort of space or science background. So my dad pretty much told me the little bit he knew about the missions to the moon and that, maybe one day we could go to Mars. And so that's really what first got me interested. And from then on, I wanted to learn more about space. And the more that I learned, the more interested I was in wanting to be an astronaut. And I kind of had to figure out what that was going to look like, what that would be, what would I have to do to actually get to that point. So pretty much I started out just by going to space camps, trying to learn more about space. It's pretty much just a summer camp to teach kids about space. So that's pretty much what I was doing and really figuring out what I wanted to do. So to kind of first get it out there, an astronaut really isn't a job. You can't, go to school and learn how to be an astronaut. It's not really a career that you can pick. So you have to figure out what you want to do beyond being an astronaut. What kind of career do you want to have? Because it's important to be just as passionate about wanting to be an astronaut as you are something else. But there are endless opportunities, endless different positions that you can take to be an astronaut. You know, you could be a pilot, you could be a scientist, you could study planetary science, astrophysics, aerospace engineering, you could study medicine. There are so many different opportunities and different ideas of stuff that you can study to eventually become an astronaut. So that's really the first step, and really what I had to figure out in terms of what I wanted to study to eventually be an astronaut. But currently I am a college student. I am studying astrobiology, and I'll cover a little bit more into astrobiology in just a minute, but pretty much what I'm doing is building a resume to eventually apply to the astronaut selection process. So after, you have to have at least a master's to apply as an astronaut. So I'm getting to that point to apply as a master's, but also at the same time, I'm getting anything on my resume that I think will look good, anything that I think will help in the selection process. So that's why I've done any sort of extras that I can. So although I'm studying astrobiology, I got my pilot's license, and I am involved with spacesuit evaluations and microgravity flights and all sorts of research campaigns, just anything to add to the resume. So that's pretty much what I'm doing. And that really applies to almost any job. You know, you want to have the bare minimums, but you also want to have any sort of extras that help you stand out. So I ended up going down the route of astrobiology. Astrobiology is pretty much just science in space. A lot of people jump to aliens when they hear astrobiology just because they think that makes sense. And, you know, it's not wrong. Astrobiology does cover aliens as well. But pretty much, like I said, it is science in space. So you could study bacteria in space, plants in space. If you wanted to study planets as a whole, you could, you know, wanted to see if we could find another planet that's similar to Earth. So that's really kind of what astrobiology is, and kind of what we study. So the thing that I love about it is that you can always jump around between what you're interested in. You know, if at this point in your life you want to study plants in space, that's great. If later on you want to study something else, that's also great. So that's kind of what my favorite part about it is. Probably right now I'm leaning more towards like the bacteria in space. I'm a big fan of growing little bacterias and figuring that out. So that's kind of where my interest is right now. But really, like I said, the ultimate goal would be to go to Mars. There's a lot of stuff happening right now in the space industry. Of course, there's the idea of going back to the moon and then eventually on to Mars. And so kind of the idea of going back to the moon, one, to really just go back to the moon. We have another goal of sending the first female to the moon. And then also we want to test a new rocket. You know, this is the rocket that we will eventually want to use to get us to Mars. It's called the SLS Space Launch System. But we also need to make sure it's all working. You know, Mars is a pretty lengthy journey. It takes about 6 months right now to actually get humans from Earth to Mars with our current technology. And so we want to make sure that everything is good, everything is working with the rocket. So that's why we want to go to the moon first, make sure everything's good, you know, have some successful missions with this new rocket, and then eventually set our sights to Mars, which will hopefully be in the early 2030s. So that's really our time frame. But really, there is a lot of exciting stuff happening right now in the space industry. So if you are interested, there is so much to see. You know, NASA recently landed a new rover on Mars called Perseverance. So there's a lot of new images. There's the first time the sound from Mars. A lot of really interesting stuff happening on Mars. Not only, you know, this past month we had NASA send the rover Perseverance, but we also had China and the UAE send stuff to Mars. So a lot of countries are really interested and involved in Mars right now. So a lot of research is being done. And then also later this year, we're hoping to have a brand new satellite, a brand new telescope, the James Webb Telescope, being launched into space, as well as hopefully the first test of that new SLS rocket. So a lot of stuff coming up in the space industry. So that's why I would like to encourage you guys to really, if you're interested, just start looking into it, because there really is a lot of stuff happening this year. And then I know that you guys are thinking of different problems and, you know, different solutions to those problems. And I really just want to throw out there real quick some of the major problems that we have, not only with the mission to Mars, but just kind of space in general. You know, a few of our major problems that we still have to figure out before we can send humans to Mars. One, how are we going to have food supply? So the mission to Mars is looking to be a pretty lengthy one. And so we're trying to figure out how we can grow food on Mars, because it's not really reasonable to like just pack food for, let's say, 6 astronauts for like 2 years. That's a lot of food. And so weight is really, really tricky in space. So we can't necessarily pack food. So we need to figure out how to grow some sort of food while we're on the mission. So that's a big challenge. Another big challenge is the radiation levels. How do we keep our astronauts protected while they're on their way to Mars? Mars has a very thin atmosphere, so there's not as much protection from radiation. So what can we put outside the spacecraft to keep us protected from any sort of radiation? And then we also have the idea of how to keep our astronauts fit and in shape in general. So actually, when astronauts go to space, they lose bone density, their muscles get weaker, they kind of get weaker in general, and that's just because when you're in microgravity, even though you guys might just be sitting in a chair right now, your muscles and your bones are still working, but in space they aren't, and so they get weaker. And so when astronauts are in space for so long, like a mission to Mars, how can we keep them fit? How can we keep their muscles and their bones strong so that when they come back to Earth, it isn't that big of a difference, and they aren't incredibly weak and have such a struggle going back to normal life. So those are kind of our three major problems with the mission to Mars, but there's also a lot of just everyday problems that we have with space. One of our biggest problems with space is actually space junk. We have so much stuff just floating out there that's non-functional, old satellites, pieces of rockets and satellites that may have collided and shattered. We just have a lot of junk, and it's all just orbiting around the Earth. And so that's a problem, because even though a little, maybe it's a little screw or maybe a little piece of paint, it may be really small, but it can definitely cause a lot of big damage. And the reason for that is because it's traveling so fast. So apologies, I'm going to say this in miles per hour, but you guys can convert it because I'm not sure the other way around, but typically stuff orbiting around the Earth is traveling 17,500 miles per hour. So that is pretty fast. And so even something small can cause a lot of damage. So that's why space junk is probably one of our biggest concerns that we're really looking to get on top of. So those are really kind of the biggest issues with space that we're facing, not only for our future plans, but just kind of space in general. Just because even stuff like space junk, we have to make sure that the International Space Station is safe. We have to make sure anything else we send to space is safe. So that's really why those are our biggest concerns. And so, yeah, I'm going to switch over and answer some questions. We can cover some more, but I have seen a few questions coming in.
So yes, there seems to be quite a number of questions that have been coming through, Alyssa. So if we start, so Krish has asked, how do you send cameras into space? Which is a really good question, because obviously we see lots of images coming from space, but how do they get up there in the first place?
Yeah, that's a great question. So it really depends. We get pictures back from space from a number of things. We have cameras connected to the International Space Station, so just connected to the outside. And the way it kind of gets connected to the outside is astronauts can do EVAs, which are extravehicular activities, or just a spacewalk. And they're able to go out there and actually connect those cameras, which can take images. A lot of pictures from space come from telescopes. So we have the Hubble telescope that's been up in space for many years that's been sending images back to Earth. And then typically on most rockets we send, we have actually cameras set up all over the place. So usually on the outside of the rocket, on the inside of the rocket, we have cameras connected to the different rockets to take video, to take pictures, and that's used kind of the entire way while it's in space. Perseverance, it takes a while for some of those images to obviously come back to us, but we do get them. The new rover on Mars, it's constantly taking images with its camera that it has embedded into it, and that's all being sent back. So that's kind of where all the photos come from. But yeah, we do have a lot of stuff that does have, that's always taking photos and videos. We like to document.
No, that's brilliant. Thank you for that. I suppose similar type of question around technology in space. We have a question that's coming from the pupils at Carradale Primary School in Argyll and Bute in Scotland. And they have asked, can you use phone and tablets and the internet in space? And they've actually specifically asked on the International Space Station.
Yeah, that's a great question. So we do have Wi-Fi in space, which is pretty nice. We have Wi-Fi on Mars, so we're all hooked up and connected. Astronauts, of course, have like computers and things like that. Typically, they don't usually have like their cell phones and stuff like that with them. They are able to like talk with their families, video chat with their families, stuff like that. Sometimes you'll see like live presentations from the astronauts on the International Space Station. They'll set up a camera and do like a Q&A on YouTube or anything like that. So they are well connected back on Earth. So yeah, we have all that hooked up. Astronauts really don't have much free time, I guess, to like watch Netflix or play on their phones or anything like that. They do have probably like an hour and a half, 2 hours every day to just kind of relax. However, most of them spend that time just looking at the window, looking at the Earth, because it is really beautiful in space. So a lot of them do that, or pick up photography, pick up some photos to send back to their friends and family. So that's kind of what we do on the International Space Station. For when we go to Mars, it's going to be a little bit trickier though, because there's a time delay. So on the International Space Station, it's only like 1 second. But on Mars, if you said hello, it would be like 15 minutes until you would hear that hello here on Earth. So we're going to have to figure something else out on Mars. But like I said, we do have the Wi-Fi and all hooked up. So
Thank you for that. That's interesting. That could be another problem about that delay on the communication over that kind of a distance. We have a question that's come in that says, this is from Sophia from India, and she has asked if you can tell her what she needs to do to become an astronaut.
yeah, that's a great question. So really the first step, if any of you guys are interested in being an astronaut, really the first step is just figuring out what you want to do. Maybe what kind of astronaut you want to do, what do you want to do in space, where are your interests? Because like I said, an astronaut isn't really a job. You have to have a job to be an astronaut. And once you kind of figure that out, because like I said, it can literally be anything that you're interested in. It's really just seeing how you can apply that to space. So your first goal is really just trying to be the best you can be at whatever that is, whether it's engineering, flying, medicine, science, any interest that you have, trying to be the best you can be. And then beyond that is trying to add any sort of extracurriculars. And there's really like none that you need necessarily. It's really just kind of whatever interests you. So I usually like to reference it, like let's say you want to do robotics. So you want to do robotics in space. Most of the extracurriculars you would have, maybe building your own robot from scratch is something awesome that you could add. Or, it's going to be different from person to person because it's going to relate to the career choice that you're going down. But really the only requirements to apply as an astronaut is to have your master's, to have some work experience, and then pass the physical to just be healthy. So really there isn't a lot of requirements. That's why it's really open-ended for trying to be the best you can be at whatever it is you're interested. But it's all about just kind of seeing how you would like to solve any problems in space, or what kind of astronaut you would want to be. So I definitely recommend that's the way to start.
Fantastic, thank you. Straight on to our next question. You talked about space junk and how this is a problem. And the question is, can you invent a space hoover to clean up the space junk? So I guess they're asking the question, but I suppose in answering it, there's a little bit about, could this be something that people could perhaps be designing for the, if you were an engineer, what would you do competition?
Yeah, totally. That's a great question. There's been a lot of ideas of different stuff of how to clean up space junk. None of them have necessarily been decided on, or we haven't necessarily picked. But to kind of give you guys an idea of some of the stuff that has been thought about, one thing is a giant net. Just having a giant net, have it orbit and just try to collect as much as we can. Another idea is some sort of laser to kind of actually knock the object out of orbit and then kind of send it, closer to Earth, and then just have it burn up in the atmosphere. And so that is another idea to kind of clean it up. There's of course been, all the way kind of like what you said, some sort of garbage system in space. Maybe some sort of garbage truck to kind of go around and collect it all and bring it to the space dumpster, whatever we can have. So there's been a lot of different ideas, but really we don't have one that we're fully settled on. So if there is an idea that you have, there are loads of it's super open-ended. There's loads of ideas that you can kind of come up with to kind of solve space junk. So yeah, that's definitely one that could work.
Okay, and just linked to that, the space junk that's there, is there value in capturing it? I know you were saying about that it could burn up in the atmosphere, but can it be recycled? Is it worth capturing it to reuse it for something else?
Yeah, that's an excellent point. Yeah, so there have been a lot of ideas of trying to figure out how we can reuse it. So everything that is really space junk is all the stuff that's like non-functional. So none of it we could like immediately grab and immediately reuse, but really we could reuse for any spare parts. Of course, it would be more expensive to like bring all the materials back down to Earth safely rather than just, burning them up in the atmosphere. So it's kind of just depending on how we want to go about it. But if there is a way that maybe we could keep the junk in space and kind of reuse it while we're in space, like I said, maybe trying to collect it, bring it to, let's say a space dumpster that we have, and then maybe that's spare parts or spare materials that perhaps maybe people in the International Space Station could dock to and go get spare parts. We could reuse it that way. That way we're not having to worry about bringing it all back down. But yeah, there's a lot of different ideas there. We're trying to figure out ways that we can recycle it. Right now, our biggest concern is really tracking it to make sure it doesn't hit anything, just because we have a lot of satellites in space from, countries. A lot of those satellites control, our phones and our internet and a lot of the ways that we stay connected. We have people up on the actual space station. So we're trying to make sure everything is tracked. And then hopefully, since it is all tracked, it would be easy to clean up once we come up with that solution.
Brilliant. Thank you very much. So Igor has asked, how long does it take to send pictures from Mars to Earth?
Yeah, that's a great question. So kind of the time delay that we have between Earth and Mars, it really depends. So the planets are all going around the sun, but they don't go around the sun in like a perfect circle. They go around the sun in ellipticals, which is kind of like an oval shape. So pretty much that means that sometimes Earth and Mars are close together and sometimes they're really, really far apart. So that's why the time delay kind of changes. On average, it's about 15 minutes, but it can be anywhere as short as like 7 or all the way up to like 25, 27 minutes. Like I said, it really depends on where the planets are. But yeah, that's usually why it takes a little bit. So, when Perseverance first landed, it was instantly taking photos, but it took us a while to kind of get those photos back, just because of that time delay. And like I said, depending on where Mars is, it changes. But yeah, it's kind of constantly shifting, depending on where both we are and where Mars is.
Thank you very much. Marnie has asked, how long does it take to get to space?
Yeah, that's a great question. So using our rockets are a good example. The space shuttle that we have been using for the past few years, typically takes 8 minutes. So from takeoff, 8 minutes later, you're in space. So really not too long of a trip. Once you get to space, things get a little bit longer depending on where you're going. So let's say you're just going to the International Space Station. It's still going to take a while to get there because you have to be going the same speed as it, catch up to it, dock to it. So that usually takes some time. It usually takes like a day for them to be fully caught up, going the same speed as the International Space Station to connect to it. So it just kind of takes some time to catch up because obviously the space station's already going around the Earth. To give you an idea, the International Space Station orbits or goes all the way around the Earth every 90 minutes. So it's pretty speedy. So you kind of have to catch up to it. But things like going to the moon typically takes 3 to 4 days, or going to Mars, we're expecting it to take around 6 months. And so there are different ideas of figuring out maybe how to shorten that mission, but yeah, really the best guess would be using bigger and better engines. But yeah, right now some of that stuff does take a while to get.
Thank you very much. So, question from Daksh, who said, I heard on the news there was a meteorite that fell in a village in the UK. What will the scientists do with that meteorite now? And how will they find out how old it is?
Yeah, that's awesome. I mean, we have meteorites kind of fall, kind of from space. I'm not like often, like it's not something to be concerned about, but it does happen, a decent bit. There's always stuff happening in space. Usually the scientists will, of course, just kind of test the meteorite, maybe try to figure out where it came from, if it's from an asteroid or things like that. Sometimes there's just space is just really a lot of dust and rocks and ice, and so there's kind of all kinds of stuff in space in general. It's possible, they would figure out how old it is. A lot of that has to do with like the different materials it is, or maybe maybe they knew of some asteroid that was passing by recently. Maybe they'll try to connect the dots there. But yeah, there's like different tests that they can run to kind of figure out some of those things. They don't necessarily know all the details of that, but yeah, pretty much they'll just try to learn more about it. But typically most of the meteorites, they aren't like super exciting. I mean, they're rocks from space, which is awesome. But yeah, usually it's just a rock that kind of fell off an asteroid, or something that just happened to make it through the atmosphere. So probably that rock was honestly pretty big to begin with, but coming through the atmosphere, most of it burns up, leaving just kind of like a little small piece that, like, probably not even that big, a little small piece that actually made it through the atmosphere that fell. So yeah, that's usually, we don't usually get much that actually gets all the way through the atmosphere.
So I guess that's why we have to go to other planets and have to go out to space to find these things and investigate them properly, because not much makes it through the atmosphere to land here to then be tested, but occasionally, obviously, it does. Our next question, we talked a little bit about this, but I wanted to just come back to it. Phoebe from Little Chalfont Primary School has asked, has space junk damaged anything in space already, like satellites?
Yeah, so we have had stuff damaged from space junk. Nothing too extreme. We haven't had any sort of like big accident. Typically it's like space junk hitting other space junk. We don't usually, I mean, we have most of the major objects, larger objects. I think we track everything up to a screw, but anything like smaller than that, it's really difficult to track. But yeah, we've had loads of like space junk hitting other space junk, which is even more problematic because that just makes even more space junk because it just falls into a lot of tiny pieces. But yeah, we haven't really had space junk hit anything too important, just because we've put in so much effort to tracking it. So a lot of our major satellites, International Space Station, things like that, they are, so we've everything that we've launched in space is set on a different orbit. So it's all, of course, orbiting around the Earth, and maybe this is going this way, this one's going this way, so they don't really cross paths. So we haven't kind of planned out. But let's say we have space junk that's maybe looks like it's headed on a trajectory to hit the International Space Station. Any of our major satellites, International Space Station, stuff like that, they have small little like engines that can make little maneuvers. So we'll just like slightly move something out of the way so that way it doesn't get hit. And that's why it's tracked, because we're constantly moving stuff around to keep everything from getting hit. So there's been, a few stuff hit other stuff, but it's all like unimportant stuff that gets hit. we put our energy into the important stuff that's actually working.
Thank you very much. Interesting question here. So obviously you're keen to go to Mars. But the question here is already thinking about what comes next. So where would you like to go, or which planet are you planning to go to after Mars? I know that there's sort of perhaps other moons and things that we can discover, so perhaps the Jupiter's moon or something, but where are you planning on going next?
Yeah, so I mean, after the mission to Mars, I probably wouldn't be making any other trips to space, honestly. Even if it was close by, after the mission to Mars is probably when I would tap out as an astronaut. And really the reason for that is just because kind of what I was talking about, the damage to your muscles and your bones. The mission to Mars is going to put a lot of time, not necessarily like damage on your body, but the more time you spend in space, the harder it is to come back to Earth. And just because you just feel so heavy when you come back. And that's just because your muscles and your bones kind of forgot what it's like to live, in gravity. And so after the mission to Mars, I probably won't be going to space again, but really the next steps, I would definitely say, like you said, a moon of Jupiter would probably be the next goal, maybe an asteroid, different ideas like that. But yeah, definitely we have ideas for after Mars. Eventually we want to keep exploring and keep going further.
Fantastic. And is that because we want to permanently live on these planets, or is it that we just want to visit and understand them better?
Yeah, that's a great question. So the idea with Mars is more of, a living situation. And that's really just because Mars is the closest planet to us. But, there's been a lot of big ideas thrown out there with Mars. We've talked about colonizing Mars. We've talked about terraforming Mars. And really the first missions to Mars are going to see, okay, how realistic are these ideas and goals, and how long would they realistically take? So the idea would be, let's say population continues to grow, we could have Mars as a second place to live on. We wouldn't have as much of a strain on resources. We can have Earth and Mars. A lot of people assume when we say like colonizing Mars, we're not talking about like ditching all of our problems here on Earth and just running to Mars. Actually, a lot of the different ideas that we're trying to figure out in terms of colonizing Mars will hopefully come up with solutions that will actually help a lot of the problems here on Earth. So let's say we figure out how to grow food on Mars using Martian soil. Maybe we can use that same technology to help areas here on Earth that maybe struggle with agriculture, maybe have a hard time growing crops. If we can grow it on the surface of Mars, I'm sure we can do it here. Or even just in general, the idea of terraforming Mars, that would pretty much mean, changing the composition of the atmosphere on Mars. So Mars is mostly CO2. We need to figure out a way to clean up the atmosphere, make it habitable. And if we come up with a solution to that, we can also use that same technology to clean our own atmosphere here on Earth. And so there's a lot of benefits between Earth and Mars. And so that's why we have the idea of going and possibly making it a home for future generations. But past Mars, it would probably just be continuing to explore, learn more. Also, there's the obvious big idea of looking for signs of life, whether that is on Mars or, there's been moons of Jupiter that we found, ice on, that we're curious if there's any life there. Just really trying to figure out, if there's anything else out there with us.
Brilliant. Two related questions. So how fast can a space rocket go, which is from Aaron? And also, how fast will the space shuttle to Mars have to travel, which is from Ravi?
Yeah, really, I guess we have limits, in space. So typically, kind of like the number I was telling you, the 17,500 is like the typical speed of, of rockets that we normally do. Typically, like going to somewhere like Mars, it may be a little bit faster. We're not necessarily traveling like at the speed of light. I feel like that might be the limit, but we're not quite there yet. We do know that we have technology. Again, it's not quite to the speed of light or anything like that, but pretty much, like I was saying, it takes about 6 months to get from Earth to Mars. We do know that we have the technology of plasma engines that can actually reduce that time from 6 months to 6 weeks. So obviously that would be a faster engine, better engine. I don't necessarily know the exact speed on that one, but that's definitely for the future. Hopefully the closer future, but the first missions will have to use those older ones that kind of go the slower speed.
Thank you. We have got so many questions today. I know that we're rapidly running out of time, so I think we can keep going if you're happy to keep going, Alyssa, to try and get through as many as we can. A couple that are related. What do astronauts eat in space, and do you eat differently in space? And then linked to that, another question that came from Carradale Primary School in Scotland was, I suppose after you've eaten, how do you use the toilet in space?
Yeah, those are great questions. So first, food that we eat in space, typically before you go to space, you'll get asked what foods do you like, what foods do you not like, and they will send a little bit of both, or try to. We can send most foods to space. Really, space food is just the same. They have, wraps and shrimp cocktail and, your typical foods. We can send just about most things. There's some stuff like bread. Bread is something that we can't send to space. That's just because, when you bite into a sandwich, all those crumbs fall, and in space, everything floats. So those crumbs can actually get into computers and things. But we will send a variety of stuff that you like and don't like. And the reason for that is your taste buds change slightly in space. And that is because there's no smell in space. So actually, when we eat foods down here, we're tasting and smelling the food, and all that kind of combines to what we actually taste. And so when we're in space and we no longer have that smell, stuff kind of tastes a little bit different. So foods that you might really like here, you might really hate in space. So that's why we usually send a little bit of both. But yeah, the astronauts do eat well. It used to be really nasty, but we've definitely upgraded. And so they have pretty good food now. And then as far as going to the bathroom in space, we have two two systems, Mr. Thirsty and the Target. Mr. Thirsty is for number 1. It looks kind of just like a tube, like a big kind of like long tube. And then each astronaut has their own like cup, which you like attach to the end, and then you pee into the cup, and it's kind of like a vacuum cleaner. It sucks everything away and sends that actually to the filtration system, and all of that is purified and reused. It's very expensive to send water to space, so we have to reuse any and everything. And then the Target is the second system, which is for number 2. And the Target, it looks a lot more like your traditional toilet, except the hole is much, much smaller. So, you know, we have a very small hole, and astronauts have to train how to line themselves up to make sure there's no accidents. There's also little bars that go over your hips to hold you to the toilet. And again, it's like a suction system. That's all sucked away. You know, airflow's pulling that all away. And that's usually how we go number 2. And none of that is reused. So in case you were thinking that, no, that is all tossed away.
Good to know that's not reused. Straight on to the next ones. I guess everyday activities and how they change when you're in space. So Tweedmouth Prior Park First School would like to know how you brush your teeth in space.
Yeah, that's a great question. So a lot of, you know, the stuff of everyday living we had to figure out when we started living in space. So for the way we brush our teeth, a lot of astronauts, well, we have different options. So we can't really like spit into a sink, right? Because if you were to, you know, spit something out, it would just float in front of you. So that's not really quite the option. So typically astronauts have the choice. They can either use like baby toothpaste, and what pretty much baby toothpaste just means that you can swallow it. So it's like healthy and fine to swallow. So usually you can swallow your toothpaste, or you can spit it into like a rag. So you can't necessarily, we don't really spit into like a sink, but we also have, you know, a little water gun. You can like get some water, get some toothpaste, brush your teeth, and either way, you know, spit into the rag or swallow.
Thank you. Again, kind of related, what happens to your sweat and tears when you're in space?
Yeah, so pretty much, so water actually like sticks to you in space in a way. So let's say you were crying, the tears wouldn't like just fly off of your face. They would actually like stick to your face. So it almost like build up into like little balls like around your eyes of the water. And like I said, it'd be stuck to you, and it's going to be like stuck to you till you like wipe it away. So, and same for sweat, you know, it's going to build up and like stick to your face. So usually we just take a rag to like get it off, and that way it doesn't like go everywhere. But kind of convenient that it sticks to us. And kind of to go a little bit along with that, that's why showering, we don't really shower in space. We try to have like a traditional shower, you know, get yourselves wet, soap, rinse it off. But the thing was that astronauts were spending so long trying to like, not like vacuum, but like get all of the water off of their skin everywhere, because it does, you know, stick to you like that. So that's kind of how it's kind of how the way like water and any sort of liquids work. Now astronauts just use baby wipes, dry shampoo, things like that don't really use as much water.
That's really interesting. Who knew that water sticks to you in space? Next question, a really good one actually. Do you believe in aliens? And I suppose when we say aliens, we're talking about any kind of life form, not necessarily little green monsters. So can you talk to us a little bit about life or different life forms in outer space?
Yeah, totally. I mean, as far as like any sign of intelligent life, you know, I definitely think the universe is too big for there not to be something somewhere. That doesn't necessarily mean that they're super close to us or anything like that, but I do think that there has to be something somewhere. Like I said, the universe is absolutely massive. But as far as something close, I definitely believe that we have a pretty good chance of finding some sort of bacterial life on Mars. So pretty much we have found loads of water on Mars, which is a pretty good indicator for possible signs of life. So we have found ice, we have found liquid water, we have found steam. And so those are pretty prime environments for any sort of bacterial life. So actually Perseverance, the new rover that's on Mars, its pretty much main mission is looking for signs of ancient life. So it's going to be going, it's like tracked the way the like different places that it's going to on Mars is where we think a river used to be, and it's going to be testing for any signs of bacterial life. But we probably won't fully understand understand if it's there, or two, what kind of bacteria it is, until we get humans there to really run some tests.
Fantastic. White Knockley Primary would like to know what the difference between low Earth and high Earth orbit is, please.
Yeah, so low Earth orbit is pretty much like where the International Space Station is. Pretty much, so the International Space Station doesn't really use fuel, right? That's why it's been up there for so long. It's going to continue to stay up there, and that's because it's pretty much stuck. So a way to think about it is like, here's the Earth. The International Space Station is pretty much always falling in a way, but the Earth's gravity is like pulling it enough, and it's far enough away to like kind of counter each other, and it's just kind of constantly going around and around and around. And that's where we have most of our stuff is in low Earth orbit. So it's close to us, we can use it. And then there's kind of like a higher Earth orbit. Again, it's the exact same concept, just a little bit further away. And so there's still, Earth has a pretty strong gravitational pull that we're able to use, but that stuff is usually like not people, all that is going to be like more satellites and things like that. But yeah, we have points in space that is basically balancing the gravity. That's what we do on other planets as well. We obviously, their gravity is a little bit different, so you have to kind of figure that out. But we have stuff, orbiting around Mars or orbiting around, other planets, and so all that stuff is pretty much just the right distance away to constantly be circling it.
Fantastic. Good question here. Does time move slower for astronauts, particularly if they're in, when they're in space, or if they're on the space station?
Yeah, that's a good question. So astronauts on the International Space Station, they use a base time. So there's pretty much like, if you look at the time zones, like I think it's GMT, whatever. I always forget what the G is, like the whatever. There's like a base time, like kind of in the middle of the time zones. And we go, plus minus either direction, around the Earth. So astronauts just stick to that, like the base time that we have here on Earth. That's just the time they go by. That's what, anyone communicating with them, they're going to be working all under that time. Time doesn't necessarily go by slower. Of course they don't really have the same sort of like time we do, because, we have daylight, we have night, but the astronauts on the International Space Station, they are circling the Earth every 90 minutes, which means that they're seeing a sunset or a sunrise every single 90 minutes. So very different experience. That's why they have a set clock that they follow to. They're like, okay, now it's 1 p.m., it may be really dark because they're on the other side of the Earth, but that's 1 p.m. that they're following. So they have time that they follow. But even on Mars, once we send people there, technically, yes, Mars time is different, but it's not going to be like enough of a difference to where, like big drama scene in a movie where we come back and everyone's, 80 years old. There's nothing crazy like that to worry about.
Good to know, thank you. So there's another, we've talked a little bit about habitation on Mars, but the question is, are there plans for 1 million people on Mars by the year 2050?
Yeah, so we have different plans. Obviously, there's the idea of colonizing Mars. I'm not sure if we'll be able to make it by 2050. 1 million is a lot. Mars is a very dangerous place at the moment. Just being on Mars, the pressure is wrong, the atmosphere is wrong. There's just a lot to just like live on Mars. So pretty much we would only be able to live in habitats. But that's really why we want to go to Mars, to figure out, how we can live on Mars. So we won't be able to like live on Mars the way we live on Earth, like having us exactly a second Earth, just being able to walk out in normal clothes. That's going to be a while away. It's just going to be, how many people we want to send on Mars, with just kind of having to wear a spacesuit every single time you leave the habitat. We have to be in the right pressure and the right like breathing environment. So that's a big goal, but it's possible. Of course we can have people living on Mars. It's just going to be a very different kind of life. We won't have the same kind of life for a while until we can figure everything out with Mars in general.
Okay, question here about technology, and does it last longer in space than it does on Earth?
Did you say technology lasting longer?
Yes.
So kind of, I guess. So, the different things that we send to space, a lot of stuff that we send to space is actually really old technology. So kind of like I was talking about, we have the engines that are going to bring us to Mars. Those are going to take 6 months. We already have the technology that can actually reduce that to 6 weeks, but we're not able to use that for the first missions. And the reason for that is because the technology basically is growing and evolving so quick and too quick for space. So if we took the time to take out all the old stuff, put in all the new stuff, test it, make sure it was safe, get it all set, then by the time we did all that, there would be something else new, something better. And so sometimes if you look inside the International Space Station, they're using like really old computers. We have way nicer stuff down here, but a lot of the technology that we use in space is actually really old. Typically, stuff that we do send to space does last for a while. Obviously, the International Space Station has been up there for a while. It has gotten upgrades throughout the years. We do send missions to upgrade it. I know like the Hubble Space Telescope, that's been up there for many years, but it has also been repaired multiple times, I think at least 3 times, by different missions of astronauts. And then typically for, stuff on Mars or different stuff like that, our average, lifespan, most stuff usually lasts about 10 years. And that's just usually as long as it lasts. Like I said, as technology gets better, it's possible they could be lasting longer. But usually the different rovers we send have lasted 10 years. And then we send another because we don't have astronauts going to Mars to go and fix them and get them booted back up. Maybe one day, but for the most part, we just send a new one to keep doing either new objectives or having newer technology to be able to do newer stuff.
Thank you. Question from Sophia. What happens if we drive a space shuttle into a black hole?
Yeah, honestly, we have absolutely no idea. Black holes are very mysterious. We do not know much about them. There is, a good bit of research going into them, but, we really don't know much. We don't know what happens if you go through one. We don't know, how close you can get with being sucked in. We really don't know that much about them. There aren't any black holes super close to us. We're not concerned about, making it to a black hole, with our technology. We probably wouldn't be able to make it to the closest black hole. But yeah, there still is a lot of research going into it just because we're curious. But yeah, there's none close to us, so at least that's not a worry. So we won't have to worry about that for a little bit.
Okay, a couple of very last quick questions. An interesting one, we've had lots of variants on this, but what do you do with your spare time when you're in space? Do you read books? And if so, what's your favorite book was also one of the questions. So double question there.
Yeah. Astronauts do have free time. They do have time to relax. A lot of them spend time looking outside the window, picking up photography. A lot of them pick up like a little hobbies. Like I said, like photography, things like that they'll spend their free time doing. Some of them just like relaxing. You do get to bring a small bag of personal items with you to space. So if you wanted to bring your favorite book to read, you do have the opportunity to do some of those things. So astronauts have done that. We have some astronauts, Chris Hadfield, he had a guitar in space. He would jam out, play his guitar, to kind of in his free time, relax, stuff like that. So different astronauts have different ways to pass their time, depends on your interests. And then as far as like favorite books for me, honestly, just a lot of different books written by astronauts telling their story. I think, Clayton Anderson has a book, Leland Collins has a book. There's a few really cool astronauts that have pretty amazing stories. So honestly, just looking up some books written by astronauts is always a good place to start.
Fantastic, thank you. There's another question here from Solby Year 4 who would like to know what materials are used to build rockets.
Definitely a lot of different materials, a lot of different kinds of metals, definitely a lot of like insulation also goes into rockets. So it depends on like the area of the rocket. Each one's kind of built a little bit different. So to kind of give you an idea, let's say the space shuttle, right? So on the space shuttle, just the small part at the top of the orbiter was the only part that astronauts were in. So that part was kind of built a little bit different. The big external tank that held all the fuel, mainly that was built with different like insulators, because there was a lot of like fuel that had to be kept at a certain temperature, and so that was built with different insulators, different kinds of special metals to like kind of make sure that fuel is in the right place. But yeah, there's a whole lot of different materials that go into it, but yeah, it really depends on like the area of the rocket, and what that part of the rocket needs to do, whether that's holding fuel, keeping astronauts safe. We have different materials for those different purposes.
Fantastic. Well, look, we have had an amazing time with you this afternoon, Alyssa.